Welcome to our YouTube Live here at the European Spaceport. We're coming to you in English.
Et en français, we'll be meeting the teams and discovering the satellite CSO-3 as it prepares for its ride on board an Ariane 6 rocket.
Our spacecraft is right here, under the fairing on top of the launcher, waiting for its journey. I'm David Cavaillolès.
And I'm Samuel Roget. In the next few hours, we will bring you live coverage of the operation right here from the launch base.
I am Paul Arberet, here at the CNES Space Center in Toulouse in the CSO satellite control room. From this room, together with my team, I will conduct the first satellite operations. We are patiently waiting for the telemetry signal from the satellite at the separation from the launcher. See you later.
We're coming to you live here at the Jupiter Mission Control Center. I'm Katie Haswell.
I'm Eleanor Valency, et bienvenue. Welcome to flight VA263
and CSO-3's journey on the road to space. And it's a hot and humid day here at the European Spaceport in Amazonian French Guiana. Europe's newest rocket, Ariane 6, is on the pad for its first commercial launch on board a French military Earth observation satellite, CSO-3. We've had a couple of delays. That's perfectly normal. Safety always comes first here at the base, and a launch can only go ahead when all the systems are green, and that's the case today. Right now we go for launch. This is mission control, 16 kilometres or so from that pad. We're in our commentary boxes overlooking the operational teams here, and you can see the boards there that everyone's looking at. I'm Katie Haswell, and joining me is David Iranzo. I'm delighted, David, to have you with us. Thank you.
Great to be here.
David is a rocket expert, so we're very lucky to have you. And in the French commentary box next to us, we have got the French team, Eleanor Valency and Samuel Rogers. Now, if you are watching on YouTube, you can pop a question in the chat box. We'll do our best to answer it. We've got several people asking, David, if there will be live cameras on board.
Yes, there will be 4 cameras on the rocket, so we are hoping to get some great shots of the launch.
Great. So let's find out now how things are progressing for the launch, and who better to tell us than the new CEO of Arianespace, David Cavaillolès. David, a huge welcome. Congratulations on the new job.
Hi, Katie. Hi, Katie. Good afternoon, and thank you very much. Indeed, this is really a great honor for me to lead a company such as Arianespace, and I can tell you that today here in Kourou, everybody is very impatient, very motivated by what is going to happen.
Indeed, it's an important launch. We've had a couple of delays.
Yeah, so as you know, last year we performed the maiden flight of Ariane 6, and it was a great success. And today is the first commercial flight operated by Arianespace. So of course, this is a very important day for us. This is the beginning of a new chapter. But this is also the beginning of a new chapter for the whole European space sector. So you're right, we had to reschedule a little bit the flight because our teams had to perform some additional operations on the ground. Now it's fixed, and I would like to sincerely thank them for their involvement and for their efficiency.
Indeed, everyone works very hard for launches. And how are the operations going for today, David?
So the last steps went very well, especially this morning we had a key milestone because we rolled back the mobile gantry that is protecting the rocket. So now Ariane 6 is standing on its pad, ready for liftoff. All the indicators are green, and now we are a little bit less than 25 minutes away from the launch.
And tell us a little bit more about our mission today.
Yeah, absolutely. So today on board, Ariane 6 is carrying a satellite called CSO-3. This is a military observation satellite. Our clients today are the French Defense Procurement and Technology Agency, as well as the French Space Agency. They are working on behalf of the French armies, and I would like to sincerely thank them for their trust. You know, at Arianespace, our job is to contribute to guaranteeing an autonomous access to space for European countries and institutions, and this is exactly what we are going to do today.
Fantastic. Thank you very much indeed, David Cavaillolès. Good luck to you and the teams. Thank you.
Thank you.
So, a reminder, if you are watching us on YouTube, remember to click the bell to subscribe and follow our launches. And a quick reminder that if you have a question for our experts, you can type it in the chat box and we shall do our very best to answer some of those during the show. So we are go for launch. Everything is green. Ariane 6 and CSO scheduled to lift off in just under 23 minutes. You can see the countdown there on the top left-hand side of your screen. David, what's going to happen after that?
So yes, Ariane 6 will lift off towards the north, powered by its main cryogenic engine and its two solid propellant boosters. There will be separated 2 minutes into the flight, followed by fairing separation. After that, the main stage will fire up to 7 minutes and 40 seconds, and once it's finished its job, it will be separated. Will be followed by the Vinci upper stage engine, which will be ignited for the first time, and for 11 minutes, putting the launcher in an intermediate orbit. After that, we will have a long coasting phase and an additional boost of just around 30 seconds. And after that, once we are positioned in the right orbit, we will be able to separate CSO-3 in the right orbit. After that, the upper stage will enter a new coasting phase before a third boost, which will slow it down, and this will be followed by stage passivation, and leading to a re-entry of the stage above the Indian Ocean. This additional deorbitation boost avoids leaving any debris in orbit, which of course is very important.
Absolutely, very, very important indeed. And of course, once CSO is released, it goes through its testing and commissioning phase. And the clue to what the CSO program does is in its name, Optical Space Component, very much a French program for observation and defence, built by a consortium led by Airbus Defence and Space, with Thales Alenia Space in charge of the optical instrument. So, a very important program for the French armed forces and indeed for their partners. "20 minutes and 30 seconds to launch." A beautiful image there of our rocket on the pad. Ariane 6 for its second launch.
Aujourd'hui indispensable à la planification et à la conduite des opérations militaires, les capacités spatiales sont pour la France une priorité nationale. Alors que les menaces se diversifient et s'intensifient, elles assurent aux armées une bonne connaissance de l'environnement stratégique et tactique et contribuent au succès des opérations. La stratégie spatiale de défense et les lois de programmation militaire visent à doter la France des moyens nécessaires pour défendre notre liberté d'accès et d'action dans, vers et depuis l'espace et garantir notre souveraineté. Soutenues par le ministère des Armées, les technologies de pointe nécessaires ont été développées pour permettre à la France de disposer de moyens spatiaux parmi les plus performants au monde. Le lancement du satellite CSO-1 en décembre 2018 a marqué le début du cycle de renouvellement des capacités financées par les LPM précédentes et inauguré la nouvelle génération de satellites d'observation militaire. Le lancement de CSO-3 clôture ce cycle. Sa mise en orbite permettra d'accroître les capacités d'imagerie militaire.
Les satellites CSO font partie du programme MUSIS, dont la maîtrise d'ouvrage est assurée par la DGA. Elle a délégué au CNES la réalisation des satellites et du segment de contrôle associé. Une fois CSO-3 réceptionné en orbite, le système complet sera en service au sein des forces pour répondre aux besoins exprimés par l'état-major des armées.
6 ans après le lancement du premier satellite CSO, CSO-3 vient compléter la constellation. Les performances de ce troisième satellite sont identiques à celles de ses prédécesseurs et sont à la pointe de la technologie et du savoir-faire industriel inégalé en Europe en matière d'observation optique de la Terre. Le CNES et nos industriels partenaires, Airbus et Thales Alenia Space, ont atteint aujourd'hui une maturité dans la capacité à développer et opérer de tels systèmes spatiaux, toujours plus complexes, répondant aux besoins de plus en plus exigeants de nos armées. Ainsi, le système va entrer pleinement dans sa phase d'utilisation, prévue pour durer encore au moins 10 ans, avec une participation active du CNES pour en assurer le fonctionnement et la qualité de service.
Les satellites CSO sont le fruit d'une coopération qui contribue à l'autonomie stratégique européenne.
Les satellites CSO sont ce qu'il se fait de mieux en observation optique spatiale en Europe. Leurs caractéristiques inégalées permettent d'échanger de l'imagerie radar avec l'Allemagne et l'Italie et d'offrir ainsi aux opérationnels français le meilleur de ce qui se fait en Europe. D'autres pays participent à la coopération, permettant de construire l'Europe de la défense en offrant à tous ces pays le meilleur de ce qui se fait en optique visible et infrarouge spatiale.
L'objectif des satellites est d'offrir aux forces les images nécessaires pour suivre et conduire les guerres d'aujourd'hui et anticiper les guerres de demain.
Dans un monde marqué par l'incertitude, la résurgence de nouvelles menaces est caractérisée par le triptyque compétition, contestation, conflit. Les armées ont besoin plus que jamais d'un outil d'appréciation autonome de situation. La capacité militaire d'observation de la Terre contribue avec d'autres moyens à répondre à cet impératif. Elle est actuellement constituée de 2 satellites identiques CSO-1 et CSO-2 employés dans des missions complémentaires de reconnaissance et d'identification. Plus précisément, elle permet de détecter, de reconnaître, d'identifier et localiser tout objectif d'intérêt de défense, de générer des données à des fins de renseignement, de ciblage et de géographie, de jour comme de nuit, en tout point du monde, dans un rythme compatible avec celui des opérations. Sous la responsabilité du commandement de l'espace, le système CSO participe pleinement à l'appui des opérations militaires en fournissant une imagerie optique visible et infrarouge, fiable, précise et au bon moment.
Les images des satellites CSO sont utilisées par de nombreux services de renseignement, principalement la direction du renseignement militaire. Le système MUSIS est en service depuis 2019 et fournit depuis plusieurs centaines d'images quotidiennement.
Nous évoluons dans un monde toujours plus conflictuel où les capacités d'observation de la France sont pleinement sollicitées. Grâce à CSO-3, la direction du renseignement militaire pourra acquérir davantage d'images, de jour comme de nuit. Cela améliorera également le délai entre 2 prises de vue sur un même site d'intérêt. Le traitement de ce flux additionnel d'images électro-optiques et infrarouges est facilité par les outils d'intelligence artificielle. Cela va améliorer la quantité et la qualité du renseignement produit, ainsi que son partage. Ce 3e satellite de reconnaissance consolide notre crédibilité auprès de nos partenaires les plus avancés dans ce domaine. C'est notre autonomie d'appréciation de situation au profit des autorités politiques, des décideurs militaires, ainsi que de nos forces déployées qui sera renforcée, de même que notre résilience.
La DGA prépare déjà la génération suivante avec le programme IRIS qui prendra la relève à partir des années 2030. Avec ses satellites aux performances et à l'activité accrue, il permettra de poursuivre les missions de CSO conformément à la stratégie spatiale de défense. Tout comme Helios et CSO, le programme IRIS s'inscrit dans une logique de coopération en partageant nos capacités d'imagerie avec nos partenaires européens. Il promeut également une logique d'export de nos satellites au profit de nos alliés.
Aux côtés des satellites de télécommunication Syracuse et les satellites de renseignement électromagnétique CERES, les satellites CSO accroissent considérablement la supériorité opérationnelle de nos forces sur les théâtres d'opération. Ils permettent à la France de disposer d'une plus grande autonomie en matière d'appréciation de situation et de décision.
So, yes, a very, very important satellite up there inside Europe's newest rocket.
Yes, it's the second time Ariane 6 will lift off from the new pad here at the Guiana Space Center, so it's an important launch for all of us.
It really is. And designing and building a rocket like Ariane 6 is a monumental task. It requires collaboration and expertise, well, from lots of different fields, really.
It involves engineers, scientists, technicians, project managers, and lots of other specialists, all working together to make such a complex project a reality.
Indeed, from intricate designs to the precise manufacturing of components, every step requires meticulous planning and teamwork. Let's have a listen in now to some of the teams involved.
Imagining Ariane 6. Imagining a heavy lift launcher. That's an immensely complex challenge. Weight, performance, power, payload capacity, etc. Everything has to be optimized with extreme precision to meet extreme conditions. For instance, the use of liquid propellants at super low temperatures. Or the thinness of the center core's aluminum casting. Less than a centimeter thick, it must be able to withstand the rigors of spaceflight. Ariane 6 is a symbol of robustness and reliability, with over 600 companies, including more than 300 SMEs, involved in its design and production. It's a truly European endeavor. Behind this cooperative effort lies a huge challenge, coordinating all the expertise, managing the huge range of partners and manufacturers so that every stakeholder can contribute their unique know-how to the project. That's what European space engineering is all about. This rocket takes shape all across Europe. The launcher's propulsion systems are built in Vernon, France. Les Mureaux provides the main stage. The high-temperature protective structures and booster propulsion systems are designed and made in Bordeaux. The fairing is integrated at Europe's Spaceport in Kourou, French Guiana, and the upper stage is manufactured in Bremen, Germany. Each partner plays their role in making Ariane 6 a uniquely capable, perfectly optimized, high-performance heavy-lift launcher. All the components then arrive at Europe's Spaceport in French Guiana. This is where the launcher undergoes final assembly. Every millimeter matters, and this process is carried out with absolute precision. Ariane 6 stands ready on the launch pad, ready to write a new chapter in European space.
And there she is on the pad, 11 minutes and 41 seconds to launch. And the teams here in the fishbowl, what we call the fishbowl inside that glass, some of the teams from Arianespace and Ariane Group who are responsible for our rocket. There they are. We call this group the flight desk, David.
Yes, here we have the CEO and CTO of Arianespace. We also have Ralf Stucker, who is precisely the head of launcher exploitation at Ariane Group, so in charge of delivering and building the launcher here in French Guiana. Yep,
very important job. Boards are green there. You can see them on the panels. We have a number of control rooms on the job today, some in Europe. We have two here in the Space Centre. We've got mission control we've been looking at in charge of the mission, and closer to the pad is launch control. What are these folk doing, David?
Yes, this is the CDL3. This is the place where the teams are getting the launch pad and the rocket ready for liftoff. These are the operations team. They are sending the various commands to turn the launcher avionics on, to fill the propellant tanks, to pressurize the tanks, and to do all the necessary checks to confirm that the launcher is ready for launch. And behind them, behind the glass windows in the back, the engineering teams are monitoring all these operations closely, making sure that all parameters are as expected. They are following all physical parameters, temperatures, pressures, electrical currents. And all these teams are also being supported in Europe by some additional teams who are there to help in case of need.
The more the merrier. Always good to have lots of people on the job. We had the final weather check about 10 seconds ago at T-10. The weatherboard is green, so that's good news. Obviously, weather conditions must be right for a launch to go ahead. And we are, of course, in the Amazon rainforest, on the edge of the Amazon rainforest here on the coast of French Guiana, so it obviously does rain a lot. But rain isn't a problem, although there are other things we need to monitor, aren't there?
Yes, that's right. We monitor high-altitude winds between 10 and 20 kilometers. We need to make sure that wind speed and direction are below a certain limit, not because the launcher could not withstand it, but for safety reasons in case of any launcher malfunction. And we also monitor lightning risk during the ascent to avoid being hit by lightning, of course. Here on the ground, we have the launch mast, the lightning mast that you see in the images here, so we are protected.
You can see here the weather center at the base.
That's right, and from here we launch the weather balloons that you see here. They are sent up into the atmosphere with sensors to capture atmospheric temperature, pressure, humidity, and from this we are able to predict precisely what the conditions would be for launch.
I've had another question coming in from Patasensa. What's the difference between the Ariane 6.2 and 6.4 version?
Yeah, so we have two versions of Ariane 6 with either 2 or 4 boosters, depending on the launcher performance that we require for the mission. Today, we only need 2, considering the satellite mass and the targeted orbit.
Now, teams have been working here at the base preparing the rocket and the satellite now for some weeks. We call that process the launch campaign. Just talk us through some of the events, some of the things they've been doing, David.
Yeah, so here you see Canopé, which is the new cargo ship, a hybrid using sails, that has transported the rocket stages from mainland Europe to French Guiana. They arrived here end of November, and they were then transported by road to the horizontal assembly building that you see here in this building. The main stage and the upper stage are mated together. We do the physical, the mechanical connections between the 2 stages, and afterwards the electrical connections. And once this is ready, the whole core stage is transported to the launch pad. There is 800 meters, and we use this automatic vehicle to transport the stage to the launch pad. We are then lifting it up and putting it on the launch table, from which it will take off. The boosters that are added to the launcher to complete the assembly of the launcher. On the satellite side, CSO-3 arrived by plane to French Guiana. It was mid-January. It was then transported to the satellite preparation facilities, where it was checked, it was fueled. And once all of this was ready, it was integrated on the satellite adapter, which is the interface between the satellite and the launcher. And this was then integrated into what we call the LVA, the launch vehicle adapter, on which we bring the 2 fairing halves to encapsulate the satellite inside and get it ready for its transport from this encapsulation building up to the launch pad. And once we get to the launch pad, that was just a few days ago, we put it on top of the launcher, and we do the final integration of the satellite on the launcher and to get it ready for launch.
Indeed, so many operations, lots of experts working there, bringing us to this point, 5 minutes and 48 seconds now to launch. But actually, the final countdown started around about 10 hours ago. There were a lot of operations during that time, weren't there?
Yes, the countdown started a few hours ago with the mobile gantry rollback very early this morning, 8.5 hours before launch. After that, all the propellant lines were flushed and cooled, and then the fueling of the launcher started around 5.5 hours before launch. And in parallel, we had the electrical checks and arming of the launcher in preparation for the launch.
À tous les vidéos, attention pour la séquence finale lanceur. Top à 0-5 minutes.
And the Range Operations Manager, Alex Serk, has announced the beginning of what we call the synchronized sequence, or the automated sequence, or automatic sequence. Ariane 6 is now becoming progressively autonomous. And again, a whole range of very vital operations now during this time, David.
Yes, all those operations are very precisely timed, combining system checks, pressurization of the cryotanks, activation of different systems and valves. And the control of the operations is gradually being handed over from the ground computers to the onboard computers. These onboard computers will actually send the last commands to ignite the main engine to check that it's working properly, and then it will command the opening of the cryogenic arms and the ignition of the boosters just before liftoff.
Those are those yellow arms you can see up there attaching to the rocket. And as we said, we've got a number of different control rooms on the job, and some of those in Europe. This is the team at every Arianespace team in Paris?
Yes, this is headquarters in Paris. Lots of people that have worked in the preparation of this launch.
Hello, everybody. Looking forward to the launch there. We've also got one of the Ariane Group sites in Ottobrunn in Germany.
Yes, this is Ariane Group's European Center of Excellence for the development and production of rocket engine combustion chambers.
Ah, go Ariane. Lots of support from there. And let's say hello now. Hello to everybody in Bordeaux, in France, another Ariane Group site.
Yes, there are several Ariane Group sites in this region in charge of booster engineering and the preparation of booster parts and high-temperature materials.
Fantastic. Everyone showing all their support there. Go Ariane 6. So, 3 minutes and 5 seconds now as we get closer to launch. Some excitement there in the various different centres, but we've got some very high concentration levels back here at the Guiana Space Centre, where we're getting very close now. A couple of things to look out for, David. Now, if you look at the two-thirds up the rocket, you can see what we call the cryogenic arms. We saw them briefly earlier. What are they doing? They're pumping cryogenic fuel into
That's right. They're pumping liquid oxygen and hydrogen into the tanks of the upper stage. They're very cold. Liquid hydrogen is minus 253 degrees Celsius. You can see them better here in this image. And oxygen is 180 degrees below zero. And yes, they are very, very cold.
Yeah, and you can't see it here, but sometimes you can see a little bit of white smoke coming out. So actually, this is the Vulcan engine we're looking at right now, the engine on the main stage. And we have an ignition sequence, don't we, David, which involves it switching on 7 seconds.
That's
before.
right. That's right. The engine will be switched off 7 seconds before liftoff. The onboard computer will check that everything is working correctly. And so once that is done, it will send the commands to open the cryogenic arms and to ignite the boosters. Once that is done, there is no holding back.
Yep, our rocket will take off. Yes, so people here in the Mission Control Center now sort of heading out, because a lot of people like to go onto the balconies to watch the launch with their own eyes. So you can see in here in Mission Control all the VIP seats, all the guest seats are empty. The boards are green. We are getting close now to launch.
À tous de DDO, attention pour moins d'une minute. Top à 0, moins une minute.
We are 1 minute to launch. Best wishes now to all the teams who have been working so hard for today. Good luck, everyone.
Bon voyage, CSO-3 on Ariane 6.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage de ESR et décollage. La propulsion est nominale. Pilotage calme.
We have lifted off. Ariane 6 and CSO-3 have started their
Propulsion
journey.
nominale.
He's telling us that the propulsion is normal. We are looking here at our cameras, onboard cameras.
Tous les paramètres à
looking
bord sont
down.
nominaux.
He's telling us that everything is going normally. I believe, David, we're looking down here at one of the boosters.
Yes, that's right. These are the onboard cameras. We have a
Propulsion
cloudy day
nominale.
today, so you can see the rocket going through the clouds.
Indeed, we've already broken the sound barrier. We
Pilotage
have.
calme, trajectoire nominale, paramètres à bord nominaux.
He's telling us that everything's going according to plan. David, we can hear our rocket coming over the Jupiter Mission Control Center, about 16 kilometers from that pad. It takes time for the noise to get to us, the rumble, as it's sometimes known in the jungle.
That's right, and we can feel now the vibrations of the boosters coming up to us 15 kilometers away.
Indeed, and it's those boosters which are doing all the work, even though we have switched on the engine on the Vulcan engine on the main stage. The boosters, well, their job is to literally boost us away from
Trajectoire nominale, paramètres à bord nominaux.
That's right. It's the boosters are providing more than 85% of the more than 800 tons that we need to take off, and these boosters will burn its 2 times 142 tons of propellant during a bit more than 2 minutes. And after that, we will have lost about 70% of the mass that we had at the time of liftoff.
That's the name of the game. The lighter we are, of course, the faster we go. Those boosters scheduled to detach in a matter of seconds. Seeing our images here on the live cameras.
Séparation des ESR.
Just a few seconds after the event, but we have confirmation that those have actually separated. As I said, the images are coming to us for technical reasons, just with a very slight delay. And he's telling us that the propulsion is nominal. And there we go. That's what it looks like in space. Those boosters falling away. The trajectory on the right-hand side of our screen.
Trajectoire nominale, paramètres à bord sont nominaux.
Everything's normal. The green line is the planned trajectory. The cross, indeed, is our actual position of our rocket. Our speed and altitude, David?
Yes, we're close to 100 kilometers now, and we're 150 kilometers downrange from Kourou, and we have a speed now of 1.7 kilometers per second and increasing.
Per second, not per hour, per second. So that's the kind of speeds we're going to be heading up towards. We'll be getting to 8 kilometers per second. Look at the images on the bottom right of your screen. That is the big main stage, the tank of fuel at the very front of sort of pointy section, if you like, is our fairing with our satellite inside. It's got a number of different jobs. It's protecting the satellite, isn't it?
Right, it protects the satellite while it's on the ground against dust, humidity, and any kind of pollution. Then it protects the satellite during the launch itself, the liftoff, because there is a lot of acoustic noise.
Trajectoire nominale.
And finally, during the atmosphere part, then it protects it against the air friction and the extreme heat that is generated by this friction.
So our satellite nice and comfortable up there in first class inside the fairing, having started its journey. That fairing will remain there for another few seconds. And of course, as we saw earlier, David, you were explaining it's made in 2 halves.
That's right, and this is the onboard camera showing the 2 halves of the fairing that will separate.
Séparation coiffe.
We have confirmation that the fairing has separated, and we'll be seeing those, hopefully, those images on our onboard camera. It actually, as it separates, David, it flexes. It's called the breathing mode. It's very specially designed to do that.
Yes, that's right. The breathing mode. Here we go. We have the separation and the breathing mode through the onboard cameras. This breathing mode is this movement of the 2 halves that happens due to the forces of the pyrotechnic separation and then the ejection forces and the flexibility of the structure.
Looking back down at our planet now, you can see that thin blue line.
La propulsion est nominale.
The atmosphere of our Earth. He's telling us that the propulsion's normal, everything's going according to plan. So we're burning the main stage. It's a great big tank of fuel. David, tell us a little bit about it.
Yes, so the main stage is a cryogenic stage. It's 32 meters tall and about 5 meter diameter. It weighs 23 tons and burns 154 tons of cryogenic propellant. And it has 2 tanks, a hydrogen tank in the lower part, an oxygen tank in the upper part. And for those who remember, on Ariane 5 we had a common bulkhead, meaning that the 2 tanks were together. On Ariane 6 they are separate. This in order to improve the handling of the pressures in the tanks.
Propulsion nominale.
And in the lower part of the tanks, we have the Vulcan 2.1, which is an improved version of the Vulcan 2 engine that we had on Ariane 5. We have improved the nozzle manufacturing. We have
Les paramètres à bord sont nominaux.
generators which are made using additive manufacturing, and we have also added a thermal protection around the nozzle in order to protect it from the heat coming from the boosters. And this will burn for over 7 minutes, increasing speed and altitude.
Separating each section of the rocket looks simple, but of course a lot is actually happening up there, and we're getting closer now to the next main event, which will be cut off of that main engine.
Yes, that's right. It's the guidance algorithm that's on the onboard computer that will detect that we have reached the right orbit for separation, and then it will send the shutdown command to the Vulcan engine. After that, we will have a pyrotechnic separation between the two stages and a set of springs that will push away the two stages. And we should be able to see it on the onboard cameras.
You can see on the bottom right is you can see our satellite CSO-3 attached to the front of the rocket, at the top of the rocket.
Paramètres à bord nominaux.
Getting close now to the next event. We call it MECO, main engine cutoff.
Extinction Vulcain.
And we have confirmation that the engine has switched off.
Séparation LLPM.
And we have confirmation that the main stage
Allumage Vinci. Fin de mission sauvegarde.
has separated, and the upper stage has switched its engine on, and that's what it looks like up there in space with our onboard cameras. That great big
Propulsion
tank
nominale.
of propellant. It's burnt its fuel. It's falling back down to Earth. So, David, the upper stage has taken the wheel. It's a little bit like a fancy orbital taxi driver, because its job is to drop off its passengers in space. Today we just have one passenger. And we've got a new engine for the upper stage. It's called the Vinci engine.
Yes, the Vinci engine is one of the big innovations of Ariane 6. It provides the mission flexibility. It is designed to switch on and off up to 4 times, allowing to take different passengers to different orbits. It's the first Ariane rocket that has a cryogenic engine with this reignition capability. For the mission today, we will use the engine twice to deliver CSO-3 to its orbit. And after that, we will use a third burn of the engine to deorbit the upper stage.
And we had the range operations manager just back there announce that we've switched on something called the APU, the Auxiliary Propulsion Unit. It's a new device that we've got on the upper stage. It performs a number of critical functions to enhance the versatility of Ariane 6. Everything's going normally. We'll talk a bit more about that, David, later in the programme, so do stay tuned. But just before we do, a shout-out for the Franco-German cooperation on the upper stage.
Yes, the upper stage, which is designed and built by Ariane Group in Bremen, in Germany, with an engine designed in Vernon, in France. And the whole thing was tested during the development of the launcher in a test bench designed by the German Space Agency.
And we picked up a signal in Bermuda. So once we release CSO-3, the French Space Agency will take on the satellite.
CNES, agence spatiale française, assure par délégation de la Direction générale de l'armement la maîtrise d'ouvrage du projet CSO. Cela va de la conception du système satellite jusqu'à sa mise en orbite et son exploitation opérationnelle pendant toute sa durée.
La trajectoire est nominale, tous les paramètres à bord sont nominaux.
Compétences métiers pointues et un savoir-faire reconnu depuis 35 ans. C'est au CNES que sont opérés quotidiennement les satellites afin de programmer les prises de vue commandées par la Direction du renseignement militaire.
Le CNES vient de recevoir les listes de programmation à envoyer au satellite CSO. L'équipe mission a préparé les automatismes permettant de transformer les listes reçues en ordre élémentaire pour chacun des satellites. Les ingénieurs mission surveillent le bon déroulement des activités pour intervenir en cas de problème et ainsi maintenir un très haut niveau de disponibilité du système pour les utilisateurs. Les télécommandes sont prêtes. Pendant ce temps, l'équipe bord veille au grain. Son rôle, assurer la bonne santé des satellites. Elle réalise des activités permettant d'anticiper les problèmes sur les satellites afin de garantir leur fonctionnement et une disponibilité maximale pour les utilisateurs. En cas d'anomalie, elle mène les investigations pour identifier la cause et réaliser les opérations de remise en condition opérationnelle du satellite. En parallèle, l'équipe dynamique de vol vérifie les résultats de la détermination d'orbite qui calcule la trajectoire réelle du satellite. Si celle-ci s'éloigne trop de l'orbite nominale, alors l'équipe programme une manœuvre de correction d'orbite. La trajectoire réelle est utilisée pour surveiller les rapprochements avec les autres objets spatiaux. En cas de risque de collision, l'équipe programme une manœuvre d'évitement. Cette trajectoire est également utilisée pour piloter les stations au sol et la programmation des prises de vue. L'équipe sol est responsable du bon fonctionnement des moyens matériels et logiciels du centre de contrôle pour l'ensemble des métiers.
La propulsion est nominale.
La surveillance quotidienne des systèmes informatiques permet d'intervenir au plus vite dès qu'un incident est détecté. La moindre défaillance est traquée et corrigée en un temps record. Elle apporte également son expertise aux autres équipes pour tout besoin d'évolution de leur logiciel. Puis vient le moment
nominal, les paramètres à bord sont
Depuis
nominaux.
le centre d'opération du réseau, CORE, les antennes prennent le relais. C'est le point névralgique à partir duquel elles sont pilotées pour émettre des télécommandes et recevoir les télémesures. La station d'Osagalicius est désormais connectée au satellite CSO en visibilité. Retour au CPCC. Maintenant que le satellite est connecté et positionné sur son orbite mission, le contrôleur supervise le bon déroulement des dernières activités. Tout se déroule comme prévu. Les télécommandes sont envoyées. La direction du renseignement militaire réceptionne les images à usage défense et les exploite pour assurer la sécurité du territoire. Quant aux images techniques, elles descendent vers le centre d'expertise du CNES pour être traitées par l'équipe qualité image. Radiométrie, géométrie et résolution des images sont affinées. Les images deviennent optimales. Ces performances seront suivies durant toute la durée de vie des satellites. Grâce à CSO-3, le troisième et dernier satellite CSO et ses nouvelles capacités, la précision atteint de nouveaux sommets. Images plus nettes, délai réduit, capacité décuplée, un atout stratégique inestimable pour la défense. Mission accomplie pour les équipes CSO du CNES.
La propulsion est nominale.
14 minutes into the flight, the rocket talks to us as it flies over. It communicates with the tracking stations. They collect the data and they send it here to what we call the CVI, or the Quick Look Telemetry team, who are at the Guiana Space Center. There they are, bottom right-hand side. He's telling us that everything's going normally, the Range Operations Manager. There they are. David, what are they doing?
So, yes, they are collecting the real-time data that the launcher is sending. This includes the status of the engine, the trajectory, the flight control. And they compare this live data from the rocket to what has been predicted. So this allows them to continuously analyze the launcher's behavior and to confirm that it is as expected.
Now, lots of people working across Europe on the rocket and the satellite. Let's hear from some of the teams.
Trajectoire nominale, paramètres à bord nominaux.
Moi, je suis le Launch Campaign Operation Manager, donc le chef des opérations de lancement sur la campagne VA263. Fred est mon député sur cette campagne, mais ça n'a pas toujours été le cas.
Sur le premier vol Ariane 6, qui était le vol inaugural, qu'on appelait aussi FM1, j'étais Elcom sur la campagne et Nicolas était mon député.
Ce qu'il faut voir, c'est qu'on va échanger nos fonctions pendant tout le début de la phase IOC, l'Intermediate Operational Capability, de manière à ce que chaque fois l'un soit en titre et l'autre soit en député, et fasse en sorte qu'on profite de la campagne en cours pour déjà préparer le coup d'après et déjà préparer les optimisations et les réductions du cycle opérationnel de campagne en campagne. Voilà, donc c'est ça l'enjeu de cette phase un peu particulière qui est le début de la phase d'exploitation.
L'idée en fait d'être deux aussi sur Senna, c'est des formes de continuité.
Trajectoire conforme à l'attendu,
du pilotage,
nominaux.
aussi dans l'amélioration de nos process de pilotage, de notre organisation, mais aussi de notre montée en compétences et en maturité technique. Donc on a besoin aussi de ça, de cette continuité sur chaque vol, parce que le système en fait il est jeune aujourd'hui, donc on est en train de le faire grandir et il est évolutif et on a besoin d'être à deux pour assurer cette continuité de manière efficace et de manière dynamique.
Donc, mon métier de directeur de mission satellite consiste à vérifier au préalable que le satellite est compatible du lanceur, donc des environnements à la fois mécaniques, électroniques, électromagnétiques, environnementaux, acoustiques, un large panel de métiers et de technicité pour valider la bonne interface et compatibilité du satellite avec le lanceur. Ici en Guyane, mon rôle de directeur de mission satellite consiste avec Arianespace à piloter la campagne de lancement du satellite jusqu'à la chronologie finale et la mise à poste par le lanceur.
Je travaille sur le projet depuis 2006. J'ai commencé par le pilotage des satellites. Ensuite, je me suis occupée de qualité image. J'ai bifurqué vers le suivi de l'instrument, donc de la charge utile fabriquée par Thales Arianespace. Et depuis 2021, je suis responsable de l'ensemble du programme pour Airbus. Sur un projet de cette envergure, des centaines de personnes ont contribué, de la phase de conception à la phase de développement, puis de fabrication et finalement de tests, et tout ça dans nos locaux à Toulouse.
Le développement de l'instrument et de ses équipements a été réalisé par des équipes Thales Arianespace très expérimentées. Pour beaucoup, elles ont déjà travaillé sur Helios 1, Helios 2, Pléiade. Toutes les activités sont réalisées sur les sites de Thales Arianespace de Cannes, Toulouse, Aix-en-Provence pour Thales CSO. Nous avons actuellement une équipe qui est présente sur le site du CNES à Toulouse pour participer à la mise à poste et aller jusqu'à aux premières prises de vue visibles et infrarouges de notre instrument.
Pour Arianespace, je suis responsable production des adaptateurs. C'est une pièce mécanique qui sert d'interface entre le satellite et le lanceur. Mon travail consiste aussi à apporter une expertise technique lors des opérations d'intégration du satellite sur l'adaptateur et sur le lanceur, et ce, dans le but de garantir la bonne intégration du satellite sur le lanceur, son aptitude de vol, jusqu'à sa séparation. Ce qui est passionnant dans mon métier, c'est que je joue en fait le rôle d'adaptateur entre le monde du lanceur Ariane Group et le monde du satellite avec notre client CNES et le constructeur du satellite Airbus. Avec mes collègues d'Arianespace, notre travail est de faire rencontrer ces deux mondes pour garantir le succès de la mission.
Oh, incredible. David, they're your colleagues. It must
The colleagues and customers both working hand in hand to make this a success.
Indeed, I think everyone can feel very proud. Right, coming up to the next major event, that will be the switching off of the Vinci engine. That's what it looks like. It's burning at the moment and has about 5 seconds left on the burn.
Première extinction Vinci.
And we have confirmation there that the engine has indeed switched off. So, the first major step now in reaching the desired orbit. We're coasting effectively now, David, without the engine. Why did we switch it off now?
Yes, well, it's a bit like a roller coaster. We have picked up speed. You can see on the curve that we have decreased a bit the altitude, and we have been picking up speed also because the Ariane 6 has been pushing us for over 20 minutes now. And we are at the bottom, and we will be climbing up using the speed that we have. In physical terms, we will be transforming the kinetic energy that the launcher has been giving us into potential energy, climbing higher.
We've got a question coming in on YouTube. Paul Graves is asking, was the air conditioning inside the fairing to keep the payload healthy?
Yes, the answer is yes, of course, while the satellite is sitting on the ground under the fairing, because we have heat and humidity here in French Guiana. We have constantly providing air conditioning to the satellite to keep it at the temperature that they require.
We're flying around at the moment on what we call an elliptical orbit. It's the shape of an oval. Imagine the Earth at one end of the oval, and our spacecraft, our rocket is effectively slingshotting close to Earth and then far away from Earth in its orbit.
Yes, that's right. At its closest point, what we call the perigee, the rocket is about 330 kilometers. That's where we are now. And at the farthest point, it's just over 750 kilometers. And it takes about 37 minutes to climb to this highest point. And once we get there, we will switch on the engine again to reach the targeted orbit.
He's telling us that the propulsion's normal, everything's going normally according to plan. Another question from Erwan, who has asked, why are there so many armed forces for this launch?
Well, in fact, the Guiana Space Center is Europe's spaceport, and as such, it is a strategic facility for Europe. Therefore, the center is constantly protected by the French Foreign Legion and the armed forces. But for today's launch, considering the nature of our passenger, there are additional forces that have been deployed to assure the security of the launch and the satellite. For example, we had some Rafale fighter jets that have been deployed around the launch site.
Yep, the Rafale, or Rafale in French, the French fighter jets, which I think Rafale means gust of wind in English.
That's right.
Yep. So, 22 minutes and 20 seconds. We are at an altitude of 328 kilometers and flying just under 8 kilometers per second. We are coasting without the engine right now. The teams at the French Space Agency, CNES, are eagerly waiting to take control of their satellite. And their mission control room, we saw them earlier, it's in Toulouse in France. Let's go over now to the project manager, Paul Arberet, and the team.
Bonjour à tous, beaucoup d'émotions ici et aussi de concentration en salle de contrôle principale que vous découvrez derrière moi, où se trouvent réunis les experts.
Good afternoon, everyone. We're all very focused here in the main control room that you can discover behind me, where our experts are together. They have designed the CSO system. So we have experts from the CNES, from Airbus, from Thales Arianespace. And for several weeks, they are going to steer the operations, ensure that all of the equipment is working properly in order to carry out this mission. So let me give you a little bit of an explanation as to what will take place for this satellite as soon as we detect that it's been separated from the launcher. It's going to start an automated sequence. First of all, it's going to deploy its solar panels. It's going to carry out several maneuvers so that its solar panels are headed towards the sun and that its antennas are headed towards the ground, to keep in touch with experts here in Toulouse. So I've asked Jean-René and Camille Souchet to join me so that they can tell you a little bit more about their job. Jean-René, you're an expert. You're in avionics and onboarded electronics architect. So you are going to follow all of the equipment and ensure that it's all working properly. And if it's not, you will come up with a diagnostic so that we can react accordingly. Once the satellite is in orbit, what do you exactly do to be able to react? We have many resources on board the satellite, as well as in the room with all of our experts, so whether they're CNES, Airbus, or TAS. And if we see that something went amiss, we are going to carry out a diagnosis in order to to find out a backup system, so we can also change the equipment if needed, because our satellite has a lot of redundant equipment, so we can change the settings at any time if needed. So Jean-René, you've been doing this job for over 30 years. You've done more than 10 launches. So how has your job evolved over the years? So it's always a very instructive job. Each launch teaches us a lot because there's never two same launches. There's a wide diversity of context, equipment. We meet very different people also during launch campaigns, and it's always very informative, and I like sharing this with my colleagues, my counterparts in other companies in the industry. We are a big team, and we work together hand in hand. And now I turn to you, Camille. You don't have quite as much experience as Jean-Renaud, but still quite a wealth of experience. You are a command control architect, so what is that? So a command control architect is the person launching the activities on board. They're in touch with the engineers, onboard engineers in the next building. We send the measures from the satellite. I get the authorizations from different experts, and I ensure that they stay aware of the operations and how they're running on the satellite. So can you explain how you ensure that you always get these operations right? So there's a procedure for each activity. Everything is validated and tested on a simulator. We also have several rehearsals. We simulate breakdowns, so we are prepared to react to any situation. So before becoming a member of the CSO team, you were working on the SWAT civil system. It's the first time you work for a defense system. Is it very different in the way you work? There are many more similarities than differences. Each satellite is different, but the operations and the way things are run are similar, so I knew how this worked, and I also got a lot of help from my colleagues who shared their knowledge with me. Well, thank you both. I'm going to let you go back downstairs
Wonderful
to your
to hear
control
from
room.
the teams
And we
there at the
are
Mission
all
Control
eagerly
Centre in
awaiting
Toulouse. Really interesting to hear what they do, and we are wishing you all the very, very best now as you get closer to taking on your new satellite. So we are coasting without the engine. We are going to take a break now for about 20 minutes, and we'll see you back here at 17:15 p.m. Universal Time. That is 18:15 in Paris, and we're going to leave you with a short film about Lego, because you may have noticed that David and I have a Lego model of Ariane 6 in our studio. Basically, Lego have a website. It's called Lego Ideas, and it's for people who have ideas for new Lego sets. And somebody's come up with an idea for a Lego set for Ariane 6. And if we get enough votes, it'll get turned into a real set. How many votes have we got so far, David?
Yes, right now we're about 6,200 votes, and we need to get to 10,000. So make sure you go and vote to make Ariane 6 Lego a reality.
Yeah, absolutely. Go on the Lego Ideas website. We will also have a QR code at the end. We're going to show you a little film, and there will be a QR code at the end that you can scan. So get your camera ready. And don't worry if you miss it, because we're going to put the film on again at the end after the break. So, yeah, let's get going. Let's get voting. This, of course, is a prototype. And I have to admit that we have already had separation of the boosters, because one of them did fall off earlier when we were rehearsing. But we've managed to put them back together again. So it's a prototype, and it will look a bit different. But watch out now for the film, Lego Ideas. Please get voting.
À tous de DDO, un peu de calme. Bientôt la nouvelle acquisition de la télémesure. Merci de reprendre vos places.
Hello again, welcome back. Here we are. Fantastic images there from the launch 54 minutes ago of the second Ariane 6 rocket to lift off from the pad here at the European Spaceport. In the French commentary box, you see here Elena Bolensi and Samuel Rogers, and I'm Katie Haswell. I'm in the commentary box in English with David Iranzo, a rocket expert from Arianespace. David, great to have you with us.
Yes, good to be here.
And Eleanor and Samuel are talking there about the potential for a Lego rocket. Lego are looking to potentially make a set. We had some votes during the break.
Yes, we've had more than 700 votes, so keep voting.
Yeah, lots of you messaging in your congratulations. Line Craftsman says, keep working, you're doing great, the launch was beautiful. Yes, it was a beautiful launch. Unfortunately, a bit cloudy here, so we didn't see it for quite so long, but we had those wonderful onboard cameras. David, it performed like clockwork.
Yes, that's right. We had a great liftoff. We had the separation of the boosters after 2 minutes, as expected. Very good views. And then fairing separation and the main stage that worked up to 8 minutes. And after that, the second stage. It did its first boost to 11 minutes, and now we've been coasting for some time, preparing the second boost ignition, which will take place in a few minutes. And we are now getting close to the north coast of Australia, as you can see on the images on the left.
Yep, and although, as you say, we've been coasting without the engine, it doesn't mean that nothing is happening up there, does it? Oh, look, there we have the New Norcia tracking
Acquisition de la télémesure par la station de New Norcia.
And we have confirmation there that we've picked up the signal.
La propulsion est nominale.
And he's telling us that everything's going
Pilotage
on.
calme.
Yep, the stuff going on.
Trajectoire nominale, paramètres à bord nominaux.
Yes, that's right. We have the APU, the Auxiliary Propulsion Unit, that has been working. The APU is a new system on Ariane 6 that provides a lot of the versatility and flexibility of this new upper stage. It has two main functions. One of them is to using a small thrust, two little thrusters mounted in the butt side of the upper stage. This thrust is used to settle the propellants at the bottom of the tanks in order to make sure that the propellants are injected into the Vinci engine as expected.
Getting up close now to the next main event, which will be the switching on of the Vinci engine. Now, this is the animation. I was talking and I didn't hear.
Deuxième allumage Vinci.
Ah, good. There we have the second switching on confirmation of
nominale.
the Vinci upper stage engine, and he says that everything is going normally. It's a short boost, this one.
Yeah. Yes, it will be around 30 seconds.
Deuxième extinction Vinci.
And we have the confirmation there that we've switched the engine off. So that's good news. And of course, the teams who are relaying all the information, the tracking.
Correct.
Everything's going well. The tracking stations send the information from the rocket as it flies over to the quick look telemetry teams, or we call them the CVI team here. There they are, David. They are now tracking our rocket. What's the atmosphere like in there?
Well, there is a lot of adrenaline as they're all focusing on what they see on the screens. There are moments of tension during the critical phases, like the liftoff and the stage separations. But of course, a lot of relief when the rocket passes successfully all these different phases.
Indeed, it's a very dynamic. He's telling us everything's normal. Dynamic and high-pressure environment, but also incredibly rewarding because this small team is essential to the success of the mission. And actually, the range operations manager is listening into them on the comms loop, and they're giving the information for him to then call out to the whole base.
That's right.
So looking here at the animation images as we fly over Australia, we've had a few more questions coming in on the chats, lots of you messaging in. Diego wanted to know, David, what do you guys offer? So Arianespace, which is the company which operates the launches, what do you offer that other launch service providers don't?
Well, at Arianespace, we offer customized launch services to our customers. We work hand in hand with them in order to tailor our launch services to their needs. In order to be very precise on the needs of the customer. Here we see the teams in the CDL, the Launch Control Center, that have done all the preparation just before liftoff, and that, of course, are now relieved to have seen the launcher launching and starting its journey into space.
They do certainly look very, very happy, actually, at the way things are going so far. We've got another question here from Our Sky Heaven, who asks, when will we see an Ariane 6 4 version liftoff? Just a reminder that we've got two versions of Ariane 6. We've got a 2-booster version and a 4-booster version.
Right, and the 4-booster version we should have the first launch a bit later this year.
Look, we can see there the tracking station in the north. That green dot on the southwest coast of Australia. The teams there tracking us right now. The space sector really is booming, I think it's fair to say, and one of the features of Ariane 6, of course, is its flexibility to deliver any type of satellite to any kind of orbit, and that really is important because there are so many different kinds of space missions, aren't there, from connecting us all to the internet to going out and looking at other planets.
Yes, that's right. We have different types of satellites that Ariane 6 will launch in the coming years, telecommunication satellites for telephone and TV. We have navigation satellites that everybody uses when they take their cars today. We have Earth observation satellites like the one we are launching today, but also for climate and weather forecasts. And we have constellations of satellites that are also being launched and that are allowed to have internet coverage everywhere. And then we have more scientific missions and exploration missions. We have launched in the past with Ariane 5, and we will do it also with Ariane 6, missions to other planets, telescopes, and all kinds of missions that for which Ariane 6 can be used.
A reminder, we're looking at the CSO satellite attached to what remains of our rocket, the upper stage. These upper stages job to deliver our satellite to the orbit that it needs to be delivered on in order for it to start its life. And our range operations manager is telling us that everything is going well. Got another question here, David, from Saudi 0001, who asks, how many contracts has Arianespace signed for Ariane 6?
Well, Arianespace has now contracts signed to launch 32 Ariane 6 in the coming years, so we are going to be quite busy covering different types of missions that I just mentioned. Just a few weeks ago, we signed 3 new contracts, one for Sentinel-1D for the Copernicus Earth Observation Program for the European Commission and ESA, which, by the way, will be launched a bit later this year. We'll sign the Galileo second generation, the first set of satellites, for the European Commission, the European navigation satellites. And also we signed Plato, which is a space telescope, a space planet hunter for the European Space Agency Science Directorate, so a telescope that will search for extrasolar planets.
That's very exciting indeed. Planets around other stars. We're finding more and more of them. Right now, right-hand side of the screen, our altitude just under 800 kilometers above our planet. We've traveled 17,000 kilometers from the pad. It's slightly reducing because we're actually coming around the other side and getting closer to our pad. And if you look at the far side, 7.55 kilometers per second is our speed. That's per second, just under 8 kilometers per second as we fly, hurtle even, around our planet. And there we are, flying over southwestern Australia. We have a question from Gabin, who says, how have you managed to reduce the size of the boosters compared to Ariane 5? That was the previous rocket.
Yes, that's right. He's right. On Ariane 5, we had 240-ton solid propellant boosters. While on Ariane 6 today, we have 145-ton boosters. But in fact, on Ariane 6, we have introduced an additional modularity to adapt the performance of the launcher to the mission. So indeed, today we have less propellant than when we had on Ariane 5. But when we will launch the Ariane 64 version, we will have twice as much, so around 580 tons, and we will have even more propellant than what we had on Ariane 5.
Now, we are going to be injecting CSO-3, our satellite, which you can see attached to the front of the rocket there, in the animation. We're going to be ejecting it into what we call a sun-synchronous orbit. Just very briefly, can you explain what that actually means, David?
Yeah, it's an orbit that is synchronized with the movement of the Earth and the Sun in such way that we always pass over a place on Earth at the same local time, so that we have the same lighting on the places that we will be taking pictures of.
Very important, obviously, for the photography. So getting close now to what we call separation of the satellite. That is the process of ejecting our satellite into space. Our upper stage is orientating the satellite. It's a very precise series of maneuvers because we have to place our satellite in a very specific and precise location, if you like, a very precise orbit, in order for it to be able to carry on its job. Now, can we see Nunosia down there on the ground? There we go, just just southwest Australia. So what's actually happening, David, up there now?
Yeah, so we're turning the launcher and the satellite in a precise way and putting it in a precise direction as requested by the satellite. And then once this is done, we will have the computer will send the separation command, and there will be springs that will gently push away the satellite. So we have now finished these orientation maneuvers, and the separation should take place in just
under a minute.
Yeah.
Looking here at the animation of the predicted plan for what's happening up there in space. Always looks like it's happening very slowly, but of course we are traveling at just under 8 kilometers per second. About 25 seconds now to the separation of CSO-3 from the upper stage of the rocket.
Extinction APU.
The APU has been switched off, he's confirmed.
Séparation CSO-3.
And we have confirmation that CSO-3 has been separated from the upper stage and ejected into space. We are looking at some very happy faces here in the Mission Control Center and here in the Launch Control Center. A big round of applause from everybody who has worked so hard. This is a very, very good day.
Séparation CSO-3 confirmée par le client.
And it's been confirmed as well by Arianespace's customers. So that's great news, David.
Yes, very, very good news. So it's a great achievement. And congratulations to all the teams, to the French Ministry of Defense, CNES, Airbus, and Thales Alenia Space in charge of CSO-3. And of course to Arianespace, Ariane Group, CNES and ESA on the launcher side that have been working in preparing this launch.
I think a big slap on the back to everybody. I think everyone can feel very, very proud of the work they've done today. People giving each other congratulations here in the Mission Control Center. Of course, the job is just finishing for some, and it's just beginning for others, because the teams who we've been chatting with and meeting
Pilotage calme.
at the French Space Agency CNES Mission Control Center in Toulouse, taking on their baby now. And we're hoping now to go to the CEO of Arianespace, who is in the fishbowl, David Cavaillolès.
Hi, Cathy. Hi, Cathy.
David, congratulations.
Yeah. Thank you.
Good news.
Thank you. This is an absolute pleasure for me today to announce that Ariane 6 has successfully placed into orbit the CSO-3 satellite. And you know, I would like to deeply and to warmly thank our client, the French Defense Procurement and Technology Agency, the French Space Agency, the Space Command, and the Ministry of Armies. Of course, after CSO-1, CSO-2, now Arianespace has successfully placed into orbit the whole CSO system, and today here in Kourou we can say that thanks to Ariane 6, Europe and France have their own autonomous access to space back, and this is a great news.
It really is, isn't it? I mean, it's an important day for everyone, for so many people, David, and it's a very important day for Arianespace.
Yeah, absolutely. As you know, we have more than 30 launches in our backlog, and for this reason, today's launch was of utmost importance. So soon we'll be focused on preparing the next mission, but by then I would like to sincerely thank all the team involved. You know, more than 13,000 people across Europe have contributed to this success. This is truly a European success, and today I would just like to thank all of these people. You guys did a fantastic job today, and sincere congratulations and thank you for that, sincerely.
And thank you very, very much indeed. David Cavaillolès, congratulations and thank you. So, the French Space Agency, CNES, is the contracting authority for the CSO space component and the mission ground segments. As we said, their teams taking on their satellite now in the Mission Control Center in Toulouse. That's in southwest France. And of course, they will all be concentrating.
De la télémesure par la station de Nunorcia et perte attendue de la télémesure.
So he's just giving us information there on the planned.
Yes.
So we're going over now to Lionel Suchet, who is Chairman and CEO of the French Space Agency, CNES.
Bonjour à tous. C'est un grand moment d'émotion qu'on a vécu tous ensemble et je crois un grand moment tout court pour la France et l'Europe spatiale.
Good afternoon, everyone. So much emotion for everyone and for France and Europe for the space sector. Why is it so moving, such a launch? Well, I think that all of the energy is focusing to this launch. And the launcher itself is prepared. By energy, I mean the energy of all of the people who have been involved and even the people who watched this event. So the programming, the technical energy that is injected in the system and has been injected for over 20 years, which is what allows our launcher to be launched. So each and every one of you allowed this launcher to this launch to be successful for our rocket and for a CSO on its board. I would like to thank Ariane Group, our clients, of course, and in particular David Cavaillolès for your first launch as CEO of Arianespace. Congratulations. We've had a few postponements, but we've managed to solve all of the issues we were faced with. So once again, congratulations, David. The General Armament Directorate, they entrusted us with this beautiful CSO, and the partners with whom we already operate these two first satellites, CSO-1 and CSO-2, and they will soon operate the third one. Airbus Defence and Space, Thales Arianespace, and all of the supply chain. You've managed to develop and design wonderful tools that work to perfection, and this is why we have this great success for France and the space industry today. Just a few words as well for all of those who helped us make sure that our base is safe. So the Armed Forces of Guiana, the BSPP, the Gendarmes as well, for all of our launches. Thank you. It is very important to us, and it's really an asset for our Guiana Space Center. But for this specific launch, there was even more safety from the defense sector, from our armed forces. So thank you as well. And now a word for my teams. I am unbelievably proud for such a launch when all of the CNES teams and all of the CNES centers work on it, the headquarters as well for the planning for both the launcher or the satellites, our partnership with the Armed Forces Ministry. We are preparing this launch system. We've been preparing it together for more than 20 years. The launch zone as well, up until the very last settings before the launch, a few hours before the launch. Of course, the base, the teams that have protected assets and populations, as well as the whole preparation of satellites. It's an extraordinary team that we have, one of the strongest bases in the world. And in Toulouse, where I am today, because we also have a satellite that is developed by the CNES here, so we have all of the project operational teams who will now start working with the satellite. Such a launch is, of course, the achievement for all of the launcher teams. They've done the job for the satellite. They're relieved. People at the base are also relieved, but it's also the beginning of operations for a satellite. It's the birth of CSO-3 in space, and so I also want to say a few words for my teams right here in Toulouse, right behind me in the operations room. They are now getting in touch with this satellite, and they're going to deploy it in the days to come. We have our project manager here with us, and he's going to tell us where we stand today and what is happening with our satellite. Well, thank you very much, Lionel. I have excellent news for you. We've acquired the telemetrics signal of the satellite. It was separated properly, and as I explained earlier, the automated sequence started. We deployed all 4 solar panels when we were over Australia. So the first minutes of the CSO-3 satellite are perfect, ideal. So of course, I would like to thank the Arianespace and Ariane Group teams. There were a few technical glitches before this launch, but they're long forgotten now with this great success. Thank you.
Great news. Just to translate for everybody, the team in Toulouse have picked up the signal from their satellite. Their baby has called home.
That's right. Very good news.
So we are all very happy. This has been a very successful mission. And a successful mission as well for our voting for an Ariane 6 Lego set, David. You've been keeping track of the votes. How many are we up to?
We've gotten around 1,000 votes during our broadcast, so it's...
Over to Phillippe Baptiste, Minister in charge of higher education.
Mesdames et messieurs, quelle joie, quelle fierté de célébrer aujourd'hui le 2e lancement d'Ariane 6. Bravo à Arianespace, bravo à Ariane Group, à l'ESA, au CNES, au CSG et à tous les partenaires européens qui ont contribué à ce succès. Bravo à chacune et à chacun d'entre vous qui avez rendu possible ce lancement. Vous pouvez savourer cette réussite majeure et je la savoure également personnellement. Je goûte la fierté de cette réussite pour l'Europe et pour la France. Ariane 6 avec à son bord le satellite CSO-3, c'est la preuve de notre souveraineté spatiale. Car au-dessus de nos têtes, la concurrence est rude, vous le savez. Nous sommes confrontés à une nouvelle donne dans le spatial au niveau mondial. Le retour de Donald Trump à la Maison-Blanche avec Elon Musk à ses côtés a déjà des conséquences considérables sur nos partenariats dans la recherche, sur nos partenariats commerciaux. Dois-je mentionner les incertitudes qui pèsent aujourd'hui sur nos coopérations avec la NASA, avec la NOAA, quand des programmes aussi emblématiques que l'ISS sont remis en cause unilatéralement par Elon Musk? Si nous voulons conserver notre indépendance, assurer notre sécurité, préserver notre souveraineté, nous devons nous donner les moyens de notre autonomie stratégique. Et le spatial en est une composante incontournable. L'espace est présent partout, de nos téléphones aux champs de bataille, dans les télécommunications, la navigation, l'observation de la Terre. Alors ce lancement joue un rôle particulier car il permet la mise en orbite d'une nouvelle capacité militaire spatiale, CSO-3, un satellite d'observation de la Terre pour les armées. Il viendra compléter le système CSO au service de notre défense, mais aussi au service de certains de nos partenaires. C'est une autre brique dans la construction de notre souveraineté. Pour cette souveraineté, nous ne devons pas céder à la tentation de préférer SpaceX ou un autre concurrent qui paraît plus à la mode, plus fiable ou moins cher aujourd'hui. Nous n'y avons pas cédé pour CSO-3, nous n'y céderons pas plus à l'avenir. Nous ne pouvons pas y céder car alors nous fermerions définitivement notre porte pour l'espace et il n'y aura pas de retour en arrière possible. C'est pour cette raison que ce premier lancement commercial d'Ariane 6 n'est pas simplement une réussite technique et ponctuelle. Il marque un nouveau jalon essentiel dans le choix de l'indépendance et de la souveraineté spatiale européenne. Dans le labyrinthe de la course mondiale à l'espace, Ariane 6 est le fil conducteur de notre autonomie stratégique pour toutes les années qui viennent. Nous devons aussi progresser collectivement en Européens sur la gouvernance de l'Europe de l'espace. Nous devons nous poser toutes les questions sans tabou. Pour l'Europe de l'espace, je suis convaincu que l'Union européenne doit assumer pleinement son rôle de pilote politique en la matière. Les défis sont considérables, nul ne le sait mieux que nous, mais je voudrais reprendre ici les mots de Mario Draghi qui commentait notre ordre mondial secoué de toutes parts. Nous n'avons pas d'autre choix que d'être confiants, nous devons être optimistes. Bravo à tous et je souhaite à Ariane 6 de nombreux bons vols dans le futur. Merci à tous.
Phillippe Baptiste there, the Minister in charge of Higher Education and Research in France, with some important words. We are coming now to the end of our live broadcast. Thank you for being with us to watch Ariane 6 start its commercial life. It's been a great achievement for everybody, David.
Yes, congratulations to everyone. This is an important launch for all of us, and congratulations to our customers and to France who has a new satellite.
Absolutely, and also our very best wishes to the teams now in Toulouse, Paul Arberet and the teams there taking on your satellite and flying your new spacecraft. Thanks also to the live broadcast teams, and a huge thanks to you, David, for sharing your expertise with us.
Thank you.
Very, very grateful to have you with us, David. We'll be back for the next launch, but for now, from me, Katie Haswell.
And me, David Duranzo.
Goodbye.
Goodbye.